It's getting busy at the end of the semester now.
Yeah.
This video will be about Avogadro's law. Avogadro came up with an idea that actually helped us determine what appears where in the periodic table and with what masses. So for example, when you look at water, H2O, then of course we now know that the number ratio is 2 to 1, but the rate ratio is 8 to 1 because oxygen is much heavier than hydrogen. So if you just go by the weight ratio, 8 to 1, of course you'd think the formula of water is HO8 or something like that. So they realized that the weight of each atom had to be accounted for. And so since they know the number ratio is 2 to 1, then we can determine the weight ratio of oxygen is 16 to 1 over hydrogen rather than 8 to 1. So how did Avogadro contribute to this discovery? Well, when you break apart water into the elements with electricity, okay, so you have some water here, and you apply electrical current, it generates some bubbles of gas, and you'll get hydrogen at one of the electrodes, and so you collect the gas, and you get H2 at that electrode, and the amount of oxygen at this electrode. And Avogadro's law says that for the same set of conditions, the volume of gas only depends on how much gas you have. Since water has twice as much hydrogen as oxygen, and they're both diatomic gases, then the volume of the hydrogen you produce will be twice as much as the volume of the O2. Now, one way of expressing this is that the number of moles N divided by the volume is a constant. So, for example, if you do two different experiments, have two different quantities, whatever, so N over V is a constant, assuming everything else is constant, like pressure and temperature. All right, so one of the things that we can look at is for a specific set of conditions called SDP, standard temperature and pressure. One would think maybe room temperature would be the standard temperature, but it's not. They chose the freezing point of water as 0 Celsius, which of course is 273 Kelvin. The standard pressure is 1 atmosphere, so that makes some sense. All right, so it turns out that when you have a gas at standard temperature and pressure, that 1 mole occupies 22.4 liters. All right, and so this naturally leads to a conversion factor. So we're going to use that conversion factor in a problem. So let's take a look at a problem or two. What is the volume? So this is the first problem. Is the volume of natural gas, methane, and we're going to say 4 grams at standard temperature and pressure. Okay, well we don't have moles of methane, but it's easy enough to change that. 4 grams of methane, using the molar mass of methane. And you can see that we get basically 1/4 of a mole, or 0.25 moles of methane. Now, of course, that depends on the pressure and temperature and everything, but at STP, 1 mole will be 22.4 liters at STP. And the final answer for 4 grams of methane to add STP will be all right. All right. C. .6 liters. All right. Okay, so that's about the size of a football or so. Let's look at another problem where we might have to do the conversions in a little bit different order. Okay, so how many grams of helium are in 8 liters? At STP. Okay, and well, we can kind of do some of it in our head. So 8 liters is about 1/3 of 22.4, and so 1/3 of a mole of helium. Helium weighs about 4, so we're going to guess about 4/3, or 1.33. So now we're just actually going to calculate it. So 8 liters at STP, 22.4 liters at STP is 1 mole of any gas, but in this gas it's helium. And then 1 mole of helium is 4.00 grams of helium. And the final answer is 8 divided by 22.4 times 4, 1.43. That's close to 4/3, which is 1.33. All right. So basically 8 liters, which is about 2 gallons. 2 gallons of helium at standard temperature and pressure is going to weigh about 1.5 grams. Not a lot of weight. Of course, helium is a very light gas. Okay, so this naturally extends to the fact that since it's the same number of gas molecules in a certain volume at STP, that the heavier the molar mass is, then the more dense the gas is going to be. All right, that's it for Avogadros.